Okay, so section 6.4 is all about exponential growth and exponential decay. And it sounds really difficult, but it's really not. So exponential growth, you probably should write this down in your notebook. Exponential growth just means it has to be increasing. So like, let's say you have an account with money in it. It can, if it's, as long as that's increasing, then it's growth. And if it was decreasing, then we would call that decay. So it is exponential growth as long as what's happening is increasing by a number bigger than 1. So for example, if you can see your x's are increasing by 1, as long as what's happening underneath is multiplying by a number bigger than 1, then it would be exponential growth. So for example, if you had something like this, you can see that this is being times by 2. So because you're multiplying by a number bigger than 1, if you multiply by a number bigger than 1, it's growth, exponential growth. Now, if you look at this one, you can see that as your x's are increasing, it's just going up by 1. But then this over here, it kind of looks like division. Well, it is division, but they don't call it division. They call it multiplying by a number smaller than 1. Because remember, divided by 2 could also mean dividing by 1/2. So smaller than 1 would end up being decay. So the first couple questions you have will be about that. Okay, so the next thing is actually using the function. So again, you're going to want to write this down. So the exponential growth function is y, or it can also be listed as the f of x, same thing, of a, and then 1 plus r raised to the t power. So that's the exponential growth. A stands for initial amount, and again, they will have to give you that information. The r stands for a rate, and you're going to want to make sure that you change that percent into a decimal. And the t stands for time. Okay, so exponential decay is very similar, but you can see that it is y equals a parentheses 1 minus r. So the only difference is exponential growth, you're adding the rate, and exponential decay, you are subtracting the rate. And down here, the a still stands for initial amount, r still stands for the rate, and t still stands for time. And t should be in years. So let's say, for example, a group has 500 members in it, and they're expecting a 3% growth, and then after t years. So at this point, all we can do is fill in that y equals 500 is our initial amount, so 500 will go in for a. The 1 stays. We're expecting a 3% change, and remember the 3% has to be changed to a decimal. So we're going to want to make sure that we use the 0.03. So 0.03 all to the t years. And that's all we know right now because we don't know t. Now let's say they tell us that t is in 5 years. Well, if they tell you that t is in 5 years, then we're going to have to replace the t with a 5, and then we could go on and solve. So again, y equals 500, 1 plus 0.03, all to the 5, because we want to know what it is after 5 years. And then the rest you could just do on a calculator. So this is going to simplify, 500, this is going to simplify to a 0.03, all to the 5th power, and then we could simply solve that on a calculator. So if you do the math right, you should always do your exponent first, and then whatever that is, it's going to end up being like a really long decimal. Leave it in your calculator, and then take it times 500. It should end up 579.6 approximately. So you could say about 580 members. If we're talking people, we want to round it off to a whole number. Other problems are just going to ask you to determine, is this growth, like is this written in the growth, exponential growth, or exponential decay? So an example might look something like this. The initial amount's A, and then it has something like this, all to the t power. Another example would be something like this. And again, we have to determine, is this exponential growth or exponential decay? Well, you kind of have to go back to remembering that the exponential growth was A1 plus R all to the t, and the exponential decay was the initial amount 1 minus R all to the t. So really it's about this number right here. If we're going to add R to 1, we know that this number is going to be bigger than 1. And if we're going to subtract R to 1, we know that it's going to be smaller than 1. So if you're looking over here, it looks like 1.09 is bigger than 1, so therefore it's going to be a growth. Down here, if you're looking at this one, well, this one is smaller than 1. So in order to get to that 0.93, we had to subtract. So then this one is going to be decay. And they also might tell you to find what would R be. If you're looking at this, in order to get R, well, it would be 1 plus 0.09. So the rate had to have been 9%. Because remember, when you move the decimal point back, it would go back to 9. Down here, you're trying to figure out, well, this has to be R, or R has to equal 1 minus what to get to 0.93? Well, it would have to be 0.07. So when you subtract, you would get back to your 0.93. So then your rate would be 7%.